Hi, KTI scientists. So do you remember in the last episode we were discussing significant figures? Well, exactly. Since most of us thought that significant figures are rather difficult at times, if you ratherly did it the first time, and decided, you know what, this sucks. Well, today's going to be rather simple and a little easy, if I do say so myself, since all of this might be basic arithmetic for you. So, firstly, this one is like a little game I came up with, which is called molecularly speaking. Okay, so molecularly speaking, and all of this covers molecular weights and molar mass. So if you're in university or college, you might hear somebody say molecular weight, and if you're in high school, molar mass. Simple as that. So first off, we have to define what molar mass is, okay? So the molar mass here is defined as the ratio between the mass and the amount of substance measured in moles of any sample of the compound. Okay, let me just read that again for clarification. The molar mass is defined as the ratio between the mass and the amount of substance measured in moles of any sample of the compound. Okay, so first off, we have a little problem here, in which I'll do this just an example, just to help you out. So the first one here goes like this. Ashton wanted to find the molecular weight. So first off, that's the molecular weight if you're in college. The molecular weight of sodium azide. So sodium azide is sodium, so that's a single atom, and nitrogen, three atoms of nitrogen. So sodium azide. So for that one, for 3 atoms of nitrogen, we just say azide. So sodium azide. The molecular weight of sodium azide. Help him investigate the molecular weight of sodium azide by calculating the molar mass of sodium azide. So Na(N3). So Na(N3). So I just have this written here. So first off, this one's just rather simple, since all of this is, like I said, is just arithmetic, multiplication and addition. Okay. So first off, let's start with the basics here. Start with something a little basic. Go from left to right. I always go left to right, not right from left. Otherwise, we would miscalculate this. So first off, we have sodium. Sodium right here is 22.99. So this is just rather simple. So we would just go 1 times 22.99, correct? Obviously we would do that, but for me, I just go like this. Simple as that. 22.99. I didn't need to write the 1 down. Didn't need to have to do that. I needn't have to do that because of course we get 1 times that number is itself, correct? So I didn't need to utilize that 1. But however, we have this to deal with. 3 atoms of nitrogen, so that would be azide. So that one would be azide. So if I look over here on my periodic table of elements, there's our periodic table of elements. Surprise, surprise. So we have nitrogen here, and we have to look at the mass here. The mass of nitrogen here is 14.01, and firstly, we have to look at that and go, how many nitrogens do we have in that formula? So first off, we have to look at that and go, how many atoms of nitrogen do we have? So it's pretty easy. Shock and awe. This subscript 3 tells us that we have 3 atoms of nitrogen. So first off, we just write this. 3 times, since that parentheses is telling us to distribute in a few moments, 14.01. Okay, 14.01. That almost looks like an L, and I didn't even have to do that. And of course, I'm not utilizing variables at that. So 3 times 14.01, okay? So 13 times 14.01, if you want to grab your calculator out, is a lot more easier. And of course, I'm just going to tell you what it is. It's just 42.03, okay? So now that we did that, we're going to go over here, right over here, if I can squeeze it, 22.99, okay? And of course we did 3 times 14.01, and of course we got 42.03, okay? So 42, and of course you need to line up your decimals. They told you to line up your decimals at that. Of course they did. 42.03, if I did that correctly. Yes, I did. So 42.03, yeah. Okay. And of course this one, this part of this, so now that we did our multiplication here, this whole thing is just basic arithmetic. Basic arithmetic and basic addition. And of course, you already learned this throughout kindergarten, throughout first grade, second grade, and such. So, of course, for me in this case, I usually go left to right, but you can go right to left. I don't care. So for me, I would just go like this. Watch. So I would just look at the right and just do what I usually do. So 2 plus 4. So what is 2 plus 4? Obviously, it is 6. Obviously. So if I look at 2 plus 2, well, obviously we get 4, right? Wrong. Look at this, shock and awe, and look at that there. So this one, of course, that one's gonna be 12. That one's gonna be 10. So this one here, of course, we all know what we're gonna get. 5, right? 2 plus 2 in this case is gonna be 5, because I know that 9 plus 3 is 12, and I'll write that in a few moments. Carrying the 1 here, so 9 plus 1 is 10. Carry the other 1, so that would be 1 plus 2, that would be 3, plus the other 2, that would be 5. So that would be that. So yeah. Okay. So now we're going 9 plus 0, right? Wrong. So look at this. Look at this. I'll just write these 2 here. So these are just your carriers. I would just call these numbers your carriers. So that carrier 1, the first carrier would just be 10, right? Since we did 9 plus 3, in which that is going to be 2. So for that one is 65.02. Quite a genius move, I'd say. So thus 22.99 plus 42.03 is 65.02. Is that all? Oh, no, it's not. 65.02 is just singular. So for this molecular mass, all of the molecular mass that we're doing is measured in what type of unit? Let me show you. Grams per mole. And of course, that is not an A. That is just an O here. So do not count this as an A. Otherwise you might have did your alphabet wrong. So so that would be grams per mole. Okay, just think of this as an O. Okay, so grams per mole, 65.02 grams per mole. All right. Okay. Now I'm going to give you another problem, and this time I am going to give you a chance to get this out of the way, and you are going to do some addition yourself. So come back if you need to. Okay, so here's another problem here. This one just deals with something rather different. So listen to this. Mr. Steele had recently discovered calcium cyanamide. Calcium cyanamide? No, that's a rather organic name, so to speak. So first off, we have an atom of calcium, an atom of carbon, and 3 atoms of nitrogen. Okay, but he can't comprehend the molar mass of it, and by it I mean calcium cyanamide. Investigate the molar mass calculation of calcium cyanamide. There's a lot of C's in there, and I'm overusing my alliteration, which is not fair. Anyways, so let me just give you a head start on what you're going to start with. So first off, we are going to start with calcium first. So first off, we're going to start with calcium, and then carbon, and of course, shock and awe, 3 atoms of nitrogen. There we go. And of course, I do not need to write my ones here because I already know what this is. But as for that, you just have to calculate that. So pause the video first, and you are going to help me calculate these here. So you'll pause the video and come right back. Okay, so for calcium here, if we look over here, this one this time is 40.08 since it is singular. 40.0, squeeze that in there, 40.08, okay, 40.08. And now for carbon here, this one is 12.01. I need to line up my decimals here. 12.01. Okay. And for nitrogen, of course, we have 3 of those, three of them, in which shock and awe. There it is again. 3 times that is not a parenthesis. I apologize for that. Parentheses. 14.01. So now that we had 12.01, now we have 14.01. Okay, things are just going to look rather different. Okay, now that we had that, let's go ahead and do 3.1401 again. I think we did that before and got the same answer. Okay, back to this. We had a 42.03, correct? So, and of course, we're not going to have enough time for another problem here. So we might have to go rather quick. Okay. Well, let's start with that. So 40.08 and 12 point. Come on, where's my dot? 01. And then 3.1401 is 42.03. 42. Where's my line there? There's my 42 and 03. Okay. Okay, there we go. So now for me, let's just go left to right. Or you can go right to left if you'd like, or follow along with me if you'd like. If you just want to fail arithmetic. Okay. Or you can just want me to go right to left if you'd like. So for 4, 1 and 4, this one is just rather easy if you take my word for it. This one is just 9. Okay. This one here is just 9. All right. So that one is just 9. Okay. Since 5 plus 4 is 9. Okay. So now for this one here. You just have to be really careful about this. This one here is just like this. So for 2 plus 2, 2 plus 2. Well, think about it. 2 plus 2 is just 4, right? Right. So 94. Now we have to be careful about this line here. 3 zeros. 3 zeros are just 0, right? Wrong. It's just 1, since we have this to deal with. So 1 plus 3 is 4, and plusing your 8 is just 12, okay? And I'll just add my placeholder 1 there, or just my carrier 1. All right, now that we've done that, of course, we have to place our units. Grams per, there's my O, mole. And I get a point for my nice handwriting. All right, now let's summarize here of what we did. So for molecularly speaking, we KTI scientists have successfully defined the molar mass as the ratio between the mass and the amount of substance measured in moles, grams per mole, or just mole if you like, if you will, of any sample of the compound. And that, my KTI scientists, is how you calculate molar mass.